Next section, graphical solutions of inequalities in two variables. Let's consider the following straight line, ax plus by equal to c. I am calling this itself the straight line, but actually this is an algebraic equation. But you know that the graph of this equation is a straight line. This you already know from your previous knowledge of these things. Where a and b are both not equal to 0. You also understand that a, b and c are real numbers, x and y are variables. Now a and b are both non-zero, and suppose b is positive. Being non-zero, b can be negative also, but we are considering the case where b is positive. Now if we imagine the graph of this straight line, it will look either like this or like this. Why? I mean, why should the graph be tilted in either this way or this way? What are the other possibilities? The other possibilities are these. The graph could also have been horizontal or vertical. But in order to have the graph of this equation a horizontal line, we need a to be equal to 0. That is not the case. And to have a vertical line as the graph of this equation, we need b to be equal to 0. That is also not the case. So ruling out this and this, you are left either with this or this. The line can be more steep or less steep, that depends on what a and b actually are. Okay. Alright. Now because the line is like this or this, in this case we have drawn this one, but actually the discussion also applies to lines which are tilted like this. Any such straight line usually comes with these two arrowheads, this one and this one. Why? They indicate that the line continues on either side without any end, because that cannot be drawn, of course, so that's why normally we put arrowheads. So that means it continues without any end on that side, also on this side, and the entire straight line divides the two-dimensional plane into two half planes, the upper half plane and the lower half plane. Had the line be like this, then the upper half plane would have been this, the lower half plane would have been this, which have been numbered arbitrarily. Say this is plane 1, the lower half plane, and plane 2 is the upper half plane. These half planes are not supposed to contain the points on the line itself. Okay, so those points are different. When we say upper half plane, we mean all the points that lie above the line, and the lower half plane consists of all the points in the plane which lie below the line. Alright, but what does it have to do with inequalities? We will see. Okay. Now say you consider any arbitrary point q somewhere in the upper half plane, say here. That point q will have some coordinates, suppose alpha comma gamma. Next what you do, you draw a perpendicular from q on the x-axis. You may ask me the question, what would happen if q is chosen here? In that case also you draw a perpendicular from q on the x-axis so that it intersects this line. At some point, let that point be P. Obviously the x coordinate of P will be the same as the x coordinate of Q, alpha, but the y coordinate is something else, say beta. Now you of course see from this figure itself that the y coordinate of q, that is gamma, is greater than beta. Why? Because if you draw horizontal lines, one passing through p and one passing through q, those horizontal lines will intersect the y-axis at what numbers? The one that passes through p will intersect the y-axis here, and that is the real number beta. In fact, that is why the y coordinate is beta and the other one will be gamma. So obviously on the y-axis gamma is greater than beta, so that fact we get from how we have chosen the point Q itself. But now what will that give us here? This is what we are going to get from the fact that gamma is greater than beta. Because gamma is greater than beta, you can multiply both sides of this inequality by b and still have b gamma greater than b beta because b is positive. And then what you do, you add a alpha to both sides of the inequality, still the inequality will maintain its direction and you get a alpha plus b gamma greater than a alpha plus b beta. But note that the point p alpha comma beta lies on this line. What does that mean? It means that a alpha plus b beta is equal to c. So what do you see here? You see here that if you choose any point Q in the upper half plane, then its coordinates satisfy the inequality ax plus by greater than c, because a alpha plus b gamma is greater than c. Any point you choose from the upper half plane, the coordinates of that point satisfy the inequality ax plus by greater than c. That means all the points in the upper half plane provide us with solutions of the inequality ax plus by greater than c. Alright, but is the converse also true? Are these the only solutions? Next we are going to see that. To see that the converse is also true, suppose r u comma v is any point in the plane such that au plus bv is greater than c. That means this is somewhere in the plane. Do not look at this figure right now itself. This is somewhere in the plane, whether it's in the upper half plane or lower half plane, we don't know at this stage, okay. It is just some point whose coordinates satisfy this inequality, alright. And then what we do, we think of a vertical line, rather I should say the vertical line that passes through the point R. Wherever it is in the plane, through it exactly one vertical line will pass, and that vertical line obviously will intersect this line. Why? Because this line itself is not vertical and hence there is no option for it to be parallel to the vertical line that passes through R. So there will be intersection somewhere. Let that point of intersection be S u comma w. Why do the coordinates of S look like this? That is because S lies on that same vertical line on which R is also a point. So the x coordinates of R and S would be the same. So here it is u, there also it will be u. But the y coordinate is possibly something else, okay, say w. Then because S simultaneously also lies on this line somewhere, that's because it's the intersection of this line with that vertical line passing through R. So it lies on the line, ax plus by equal to c. So that means its coordinates will satisfy the equation of that line. That is, we will get au plus bw equal to c. Okay, now, so now you have this thing. We start with this inequality which is already with us, au plus bv is greater than c, but now additionally we also have this information that c is equal to au plus bw, and then from both sides of this inequality we can subtract au, and that will give us bv greater than bw, and then you can divide both sides by b. Not only can you divide by b because b is non-zero, but actually after division the inequality will will retain its direction because b is positive. So that gives you v greater than w. What does this inequality mean geometrically? It means that the point R lies above the point S, because the y coordinate of R, which is v, is greater than the y coordinate of S, which is w. And now only that tells us that so the point R u comma v lies in the upper half plane too. Why? Because the point S was the point of intersection of this line and the vertical line passing through R. So S lies on the line somewhere and R lies somewhere vertically above S. So obviously it lies in the upper half plane no matter where the location of S is. So that tells us, along with what we did previously, that not only are the coordinates of all points in the upper half plane solutions of this inequality. This inequality means the inequality Ax plus By greater than C, but they are the only solutions. And that is why, let me write that thing here somewhere. We write the conclusion like this. So the coordinates of the points in 2 means the upper half plane in this case are precisely the solutions of this inequality Ax plus By greater than C. What does it mean for them to be precisely the solutions? It means that they are solutions and they are the only solutions. And that is why we call this half plane to the graph of this inequality Ax plus By greater than C. We solved linear inequalities in one variable already in the previous section, and there also we drew graphs which we called solution sets. In this case these are also solution sets, but there things happen on the real line. Here things are happening in two-dimensional plane because we have two variables x and y. Recall that in our previous inequalities we only had x. That is the difference. But what about that other case where b is less than 0? Something similar will happen. Depending on what the situation is, the graph will either be the upper half plane or the lower half plane. Okay, so that's the only difference. I mean, whatever we are having here, the opposite will happen in that case where b is less than 0. But the consistent thing here is that in any such inequality, for any such inequality, the graph will be either the upper half plane or the lower half plane. Determined by what? Determined by the straight line whose equation is Ax plus By equal to C. Let us test this, whatever we did here, with this concrete inequality. Actually, this is something we considered in the beginning of the section. Beginning of the section means beginning of the previous section, not this one of course. 40x plus 20y less than or equal to 120. Do not be afraid to see less than or equal to here. We will see what that means, okay, in the context of our present discussion, because we had the discussion about a strict inequality not greater than or equal to, but still it's not a very big problem. So first what we have to do is we have to consider the straight line 4x plus 20y equal to 120, and we need to draw the graph of this, we need to draw the line, okay. So because it's a straight line, it's enough to know only 2 points on it, which can easily be found by putting one of the variables, 0 for one of the variables in the equation and then finding the value of the other one. So if you do that, say you put x equal to 0, then you are getting 20y equal to 120. Then y becomes 6. So that way you get this point 0, 6. Similarly, substituting 0 for y, you will get x equal to 3. So 3, 0 is another point, and these 2 points determine the line. And this line obviously divides the plane into 2 parts, lower half plane, upper half plane. There is no rule for naming these planes 1 and 2. There is no hard and fast rule that you have to name the upper half plane 2, the lower one. You can name them anything, okay, not even Roman numerals. You can use A, B, anything, any name. Now the question is this: from our discussion we know that the graph of this will be either this or this, but along with that the points on this line will also be included. Why? Because we have less than or equal to. So it's not just simply a strict inequality like this. This straight line is also included in this inequality. Alright. Now the only thing we have to decide is this. Is it this one or this one? We already know from the discussion that it is exactly one of them. Either it's this one or this one. But how do we decide? Well, you just pick an arbitrary point from any one of these half planes, substitute the values of their coordinates and see if the inequality is satisfied. Say you pick one point from here and substitute the coordinates here. If the inequality is satisfied, then you know that yes, this is the half plane which represents all the solutions of this inequality. But if it is not satisfied, then it will be the other one. That's just it. Now, instead of taking an arbitrary point, it is almost always convenient to take the origin, because substituting 0 for both x and y makes everything so easy. So what will you get if you put x equal to 0 and y equal to 0 here? You would get 0 less than or equal to 120, which is true. So that means this point, the origin, is actually a solution. You have to understand the context, okay. The origin itself is not a solution, but it provides us with a solution in the form of its coordinates. That's what I mean when I say the origin itself is a solution to this inequality, which means that from theory we know that all the other points which lie below this line are also solutions of this inequality, and they are the only solutions, along with the points on the line. And that's just it. Do you see how easy it is? But how will you indicate that fact in the diagram itself? You can do that by drawing parallel lines like this, indicating the fact that it's the lower half plane we are talking about, which is the graph of the inequality along with the line itself. And to indicate the fact that the line is also included, we have made these lines touch the line. Otherwise, we would just stop short of touching that line. Okay, these lines would have to be drawn in a way that they just don't touch the line, but they indicate that we are only considering the points strictly below the line. And this is how you can actually write the solution. Since 40 times 0 plus 20 times 0 is 0, which is obviously less than or equal to 120, the point 0, 0 is a solution of the inequality. So its graph is 1. This part I have written briefly because I do not have much space here, but you can write it elaborately. So the graph is, you don't just write 1. So the graph consists of all points in the plane which lie below the line this, along with all the points on the line. That's how you can write the final conclusion. So that is the graph of this inequality.